Chiron Corporation provides hardware and software to broadcasters to allow them to generate video graphic overlays on broadcast. You've seen these on Fox News, CNN, Super Bowl. Anytime there's textural data or graphic data overlaid on top of a video broadcast, it's being generated through a device called the character generator, and there's a very good chance it's one of Chiron's. I've developed several plugins for their character generator. One of them is called PowerCharts. PowerCharts is what's called a geometry plugin, meaning that it generates 3D geometry that is then used within the character generator to do specific things, such as in this case a line graph. This is several pieces of individual 3D geometry. There's the line, there's a frame, there's a background, there's curtains, there's a bunch of other things. And as you can see, as I rotate this around, this is in the 3D space. What my software does is it takes the individual data points from a data provider and then plots those data points and then extrudes a 3D element through those data points to generate the line that we see here. For sake of clarity, I'm going to turn a few objects off, namely the labels and a couple of things here. Let's turn off the frame and the various borders and the cutouts and what else do we have? Oh, the curtain. Let's turn off the curtain as well. And the grid. We'll turn off the grid just so we can look at the line. Okay, so here we have the line, and again, the line is an extruded. Well, there's one other object that's on here. It's the bottom border. The line is an extruded object that's in 3D space, as you can see. And if I zoom in on it, we can see that it's a. And if I turn on the wireframing, we can see that it's basically a series of lines that represent the outline of this extruded ellipse. Each of these data points, as we can see here, is an actual ellipse, and what my software does is it calculates where those ellipses are, calculates the angle in 3D space of the ellipse such that it is angled properly between the two data points, then distributes around the perimeter of the ellipse, calculates the XYZ points of the individual segments, and then generates an OpenGL quad strip that runs the length of the line. That quad strip is what we see here. There's several parameters on the 3D primitive for the line that we can see here in the line control chart, the line control parameters rather. For instance, the number of sides that are being drawn. As I bring that side count down, we can see that the more and more sides are added, and as we make the solid rendering on this, we can see that the more and more sides that are drawn, the more this begins to actually look like a solid object. The fewer lines, it begins to look more angled, chiseled, and which can actually be a desired effect. So yeah, now this is, let me zoom back out a little bit here. So this looks like it's being drawn on a flat surface. This is actually being drawn on a frame that is actually a sector of an ellipse. Here I specify in the controls what the minor and major axes of that ellipse are, and the start and end angle of the sector. So just to exaggerate this a little bit, let me change these parameters so we can go ahead and see that. And here we see that we have a 180 degree sector of an ellipse with major and minor axis of 1, and now the line segment is being drawn around that. If I enable the frame here, we can see that the frame is now in fact that piece of geometry as well. So let's go ahead and take a look at what we can do within the program itself, because these lines are being generated on a frame-by-frame basis. For instance, this particular character generator right now is set up to render at 30 frames per second at HD resolution. every frame that that the character generator renders, it then tells the geometry plugin to reconstruct itself. So this data is all pulled in, generated, and recalculated real time at the frame rate, whatever the character generator is running at. So we can change the amount of data. All of the data for this particular line is being pulled in through these elements that are available to the operator or to a newsroom system. As an example, if we want to change this to be, say, the last 120 days, we can do that, and obviously the data set changes. And again, all these variables are keyframeable. So you can see down here on the timeline, I'm going to move to 1 second into the animation. And if I, for instance, change the line, just arbitrarily change the number of sides. Now, as we run the animation, we can see on the line that the number of sides are changing as I scrub through the timeline. So there's numerous other things that the plugin does. All of these elements are available for texturing. In addition to calculating the OpenGL quad strips for each, the vertices rather, for the OpenGL quad strips, each vertice, I'm of course calculating what the normal is, so the lighting model can be, will light this properly, as well as the UV parameters, such that textures can be overlaid on and laid down on top of the model. So that's pretty much it for a very, very quick overview of PowerCharts. I've also developed probably about a dozen other plugins for this particular product that deal with data acquisition, data control, display, formatting, so on and so forth. But this is just a very, very quick sample of some of the work that I've done. Thank you very much, and look forward to showing you guys more. Bye-bye.